oxides. So, in Unit 1, Inorganic Chemistry, the first topic is oxides. So, what are oxides? What are oxides? Any one of you please define oxides. So, oxides are, these are binary compounds. Binary compounds formed by reaction of an element with oxygen. That is called oxide of that particular element. Oxide of that element. Simple example. When carbon, one of the elements, reacts with oxygen, the resultant compound is said to be carbon oxide. Of course, it is carbon dioxide. Similarly, S plus O2, SO2, Na plus O2, Na2O. Of course, we have to balance. It has to be balanced later. So, time being, we're trying to understand what are oxides. Oxides are binary compounds, and an element reacts with oxygen. Resultant compound is said to be the oxide of that particular element. Examples for different oxides are carbon dioxide, sulfur dioxide, sodium oxide, like this. Now, we talk about the classification of oxides. Classification of oxides. Oxides are classified in two categories. One is based on nature. Based on nature of oxides. You choose any oxide and identify its character. Whether it is acidic in nature, it has to be called as acidic oxide. If it is basic oxide. If it shows both acidic and basic characteristics, it has to be called as amphoteric oxide. It neither show acidic nor show basic. It acts as a neutral one. Therefore, it is called neutral oxide. Therefore, based on nature, oxides are classified into the following categories: acidic oxides, number 2, basic oxides, number 3, amphoteric oxides, number 4, neutral oxides. So this is based on nature of oxides. The another one is based on the content of oxygen. Based on content of oxygen. Based on content of oxygen or amount of oxygen. So these are classified as normal oxides. Number 2, you may treat as this one, ABC, normal oxides. Another one is polyoxides. Polyoxides. In polyoxides, we have peroxides. In this, we have peroxides, superoxides, 3 dioxides. Dioxide. This is a polyoxides are further classified into peroxides, superoxides, dioxides. Besides this, another one is we have suboxides. Suboxides. The last one is mixed oxides. Mixed oxides. So this is the basic classification. One is based on nature of oxides. Another one is based on amount or content of oxygen. Now one by one we will learn. First one, acidic oxides. Any one of you? What are acidic oxides? Please give examples for acidic oxides. Simply, I can say all non-metal oxides are treated as acidic oxides. Examples, non-metal oxides. You take CO2, carbon is non-metal, it's oxide, carbon dioxide. It is a non-metal oxide, it can be treated as acidic oxide. Take nitrogen pentoxide. Nitrogen is non-metal, its oxide is again acidic oxide. Sulfur dioxide, sulfur trioxide, phosphorus pentoxide, chlorine heptoxide. Like this, you can take any non-metal oxide which is treated as acidic oxide. Next, so we have already seen some examples for acidic oxides. Why the non-metal oxides are treated as acidic oxide? Because you take any non-metal oxide, for example, you take CO2, which is a non-metal oxide, treat with water or dissolve in water, it will produce an acidic compound, carbonic acid. What is this? This is carbonic acid. This is the soda commonly we will drink. Another one, SO2 plus H2O. This is non-metal oxide. When treated with water, it produces an acid. This is what? Sulfurous acid. The best, another oxide is non-metal oxide, sulfur trioxide, and treated with water, it produces sulfuric acid. So, any non-metal oxide, upon treating with water, it produces acid substances. Therefore, the non-metal oxides are treated as acidic oxides. And one more thing, so these are acidic in nature. For example, when sulfur dioxide is treated with base, because as it is acidic in nature, it should react with the base and should form salt. For example, when sulfur dioxide is treated with sodium hydroxide, it forms a salt Na2SO3 plus H2. So when acidic oxide treated with base, it forms salt and water. So this is about the nature of the non-metallic oxides or about acidic oxides. Next. Number 2. Basic oxides. What are basic oxide? Simply, you take any metal, metal oxides is treated as basic oxides. Example, you take any metal, it's oxide. Magnesium oxide, calcium oxide. Like this, you can take any number of metals with oxygen, that is metal oxide. They will show the basic nature. Therefore, metal oxides are treated as basic oxides. Examples for basic oxides. What are the basic oxides? Example for basic oxides. What are the examples for basic acids? Sodium oxide, magnesium oxide, calcium oxide. Why this treated as basic oxide? Any metal oxide, when treated with water, they produce metal oxide. When treated with water, they produce metal hydroxide, sodium oxide, sodium hydroxide, calcium oxide, calcium hydroxide, magnesium oxide, it produces magnesium hydroxide. So, any metal oxide when treated with water, they form metal hydroxide. All metal hydroxides are basic in nature. Therefore, metal oxides are treated as basic oxides. For example, when the metal oxide treated with any acid, because with this metal oxide have basic nature. As they have basic nature, they must react with acids. For example, when magnesium oxide reacts with HCl, it forms a salt, magnesium chloride, and H2O. So, like this, you can write. For example, you take sodium oxide. What is sodium oxide? Sodium oxide is a metal oxide and treated with H2SO4. What is the product? Sodium sulfate plus H2O. Therefore, any metal oxide when treated with acids, they form salts and water, which is an indication for their basic character. Next. Another type of oxides. What are the next type of oxides? Another type of oxides are mixed oxides. Category 3 are mixed oxides. Sorry, amphoteric oxide. Amphoteric oxides. What are amphoteric oxides? Oxides shows acidic character as well as basic character. They will show both the characters depending on the situation. These are called amphoteric oxide. For example, you take zinc oxide and aluminum oxide. Of course, though these are metal oxides, but these will have both acidic and basic character. For example, if you take zinc oxide and it is treated with acid, what happens? As it is reacting with the acid, it acts as a base. So therefore, when a base reacts with acid, it forms its salt and water. The same zinc oxide and treated with base like NaOH. So NaOH is the base, and the metal oxide, of course, when this particular oxide is reacting with metal means the base means it should show the acidic character towards. What it gives? It gives sodium zincate. That's H2O. Zinc chloride. So like this, This zinc oxide or aluminum oxide, they are reacting with both acids and bases and forming these salts. Therefore, these are said to be amphoteric oxide. You can write equation for aluminum also. When aluminum treated with acid like sulfuric acid, it produces aluminum sulfate. When aluminum is treated with base like sodium hydroxide, sodium aluminate is formed. So you can practice the equations for the reactions. Next one, the last one in the oxides based on their nature is our neutral oxides. Neutral oxides. What are neutral oxides? They never react with acid. They never react with base. That means they neither show acidic character nor show basic character. Such oxides are said to be neutral oxide. Example for neutral oxides, this carbon monoxide, this nitric oxide, this nitrous oxide are treated as neutral oxides. Of course, these are non-metal oxides, though these are non-metal, they will show the neutrality. That means they neither show acidic or basic character. They won't react with acid, they won't react with the bases. This is the classification based on the nature. Now, the another type of classification based on the content of oxygen. Content of oxygen. Sorry. So now, based on the content of oxygen, they are mainly classified as normal oxide, polyoxides, suboxides, and mixed oxides. Normal oxides, polyoxides, suboxides, mixed oxides. So now, what are normal oxide? What are normal oxides? Any one of you? So in these oxides, oxygen is satisfied by its normal valency. Normal oxides are oxides in which oxygen is satisfied by its normal valency, that is 2. For example, you take H2O. So what is the valency of oxygen here? 2. It is connected to or it is bonded to 2 hydrogen. You take sodium oxide. What is the valency? 2. That's all. Even calcium oxide, magnesium oxide, take calcium oxide or magnesium, here this is -2, this is +2. Therefore, the normal oxide, oxygen fulfills its valency. And one more important point here is, in any normal oxide, the oxidation state, this is very important, oxidation state of oxygen is -2. Valency never be minus, but oxidation state may be positive or negative or fraction. So this is about normal oxides and their examples. Next, polyoxides. Polyoxides. What are polyoxides? Again, these are classified into different categories. One is peroxides. What are peroxides? What are peroxides? So in these peroxides, not only this element oxygen bonds, besides the element oxygen bonds, like normal oxides, there exists OO single bond. OO single bond is called peroxy bond. OO single bond is called peroxy bond. So therefore, peroxides are a compound in which peroxy bond, that is OO single bond, exists. Besides an element of oxygen single bond. For example, you take any peroxides like sodium peroxide, barium peroxide, calcium peroxide. In this, for example, what is sodium peroxide? There must exist peroxy bond at a over single bond. Beside this, it is connected to Na plus. This is connected to another Na plus. So element oxygen bond, barium peroxide, oxygen single bond, Ba plus, Ba plus. Again, like that calcium peroxides. So there exists peroxy bond and element oxygen bond. And here one has to remember the important point is the oxidation state. Oxidation
कट कर दो
oxidation state of oxygen. Oxidation state. So the oxidation state of oxygen is -1. And one more important point, any peroxide, any metal peroxide, when treated with dilute acids, they produce hydrogen peroxide. Any metal peroxide and treated with acid, dilute acid, they produce hydrogen peroxide. Of course, salt will also be formed. Similarly, you take barium peroxide and treat it with sulfuric acid. Again, H2O is formed and barium sulfate is the salt. So this is about the peroxides. What next? Peroxides. Then superoxides. 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 These are also metal oxides like potassium superoxide, rubidium superoxide, cesium superoxide. As the size of the alkali metal increases, their characteristics to form the superoxide increases. Right. So when potassium reacts with oxygen, it produces potassium superoxide like rubidium superoxide, cesium superoxides. In these superoxides, there exists superoxide ion that is called O2 minus ion. In peroxides, O2 2 minus ion. In oxides, O2 minus ion exists. So here the oxidation state is -2, here -1, here -1 by 2. So therefore, the oxidation state of oxygen is minus 1 by 2. Minus 1 by 2. Then, so this is about superoxide. Next, dioxides. Dioxides. What are dioxides? Example you take lead dioxide, manganese dioxides. So there looks like, what is this? There looks like peroxides, but they are not peroxide. They has to be called as dioxides, lead dioxide, manganese dioxide. So this is the peroxide. When the peroxides reacts with acids, and peroxides reacts with acids, and they produce hydrogen peroxide. But these never produce hydrogen peroxides and treated with acids. So therefore, these are treated as dioxide. For example, when you react the lead dioxide with any acid like HCl, it produces lead chloride and chlorine as H2O. That's all. Similarly, when lead dioxide and treated with H2SO4, it forms lead sulfate. It forms lead sulfate. 2 moles of this one gives 2 moles of lead sulfate plus water and oxygen. They are not giving hydrogen peroxide. So that one has to distinguish the difference between the peroxides and the dioxides. This is all about polyoxides. Now suboxides. What are suboxides? What are suboxide? So for example, suboxides. Example C3O2. C3O2 is called as carbon suboxide. In this suboxide, there exists metal oxygen bond. Not only that, there exists less oxygen than the required for the normal valency. As per the valency rules, it may require certain extent of oxygen, but than the valency rules, there exists less amount of oxygen. These are called suboxide. For example, C3O2. So what is its structure? CCC. This is the structure of carbon suboxides. There are 3 carbons connected with double bond, and this oxygen and this oxygen another end. Of course, you have boron suboxide, B6O. You may have boron suboxide and rubidium suboxide, RB9, O2, etc. are also there. This is suboxide. Last one is what? Mixed oxides. What are mixed oxides? There are 2 or more than 2 oxides in combined state, and they appear as one oxide. Those are said to be mixed oxides. Or simply, for example, let me give one example. Pb3O4. What is the Pb3O4? It is called red lead. Red lead. So this is a mixed oxide. Why? Because this is equal to, it is equal to lead dioxide plus 2 moles of lead monoxide. 2 moles of lead monoxide and 1 mole of lead oxide combined state, and that gives a formula Pb3O4 because 2PbO is a mixed oxide. The next one is Fe3O4. What is this? Ferroferric oxide. Ferroferric oxide, which is equal to ferric oxide, Fe2O3, and ferrous oxide, FeO. So, in this mixed oxide, you see, same element with a different content of oxygen. That means same element exists in different oxidation state. An oxide in which an element is existing in the different oxidation states, that oxide is called mixed oxides. These are the example for the mixed oxide. For example, these mixed oxide, when treated with acid, they produce salts. For example, you take this Fe3O4, this is ferroferric oxide, a mixed oxide, treat with HCl, it reacts with 8 moles of HCl, and it produces 2 moles of ferric chloride and 1 mole of ferrous chloride plus 4 moles of water. So what it indicates? So mixed oxides, when treated with acids, they form salts. That's all. So this is about the oxides, their classification, and some important points, especially oxidation state. In the next class, we will discuss about the structure of all this oxide. So now I would like to stop at this point. If you have any queries, please raise hands. Any one of you? So otherwise, I would like to stop at this point.